Record button now. Okay, it says it's recording. So let me bring up the Word document and then we can get started. Okay. So today we're going to talk about the area of circles. Is that showing up okay? You can see where I'm writing this?
Yes.
Okay. So we're going to find the area of circles given the radius and diameter. So if I'm given a circle, my radius is from the center of the circle to any point on the circle. So that distance is the radius. Okay. If I have a circle and I have the center and I have a line going from one point on the circle through the center to another point on the circle, that's the diameter. So this whole distance is the diameter. So if you're working a problem and it gives you the diameter, you want to take half of it and then plug that into your formula. So write that out. If given the diameter then divide it by 2. Then use formula. For the area of a circle, which is pi times the radius squared. I need to scroll down to start working through problems, but I want to make sure you've written down what you need to. And I'm also going to save this file, this Word document, and then email this out with the video link. Okay, so I'm going to scroll down. If I need to go back up, please let me know. Okay, so for example, 1, I have a circle whose radius is 2. So R equals 2. So to find the area, I'm going to use the formula A equals pi times R squared. So now we want to substitute. A equals to pi times 2 squared. A equals to pi times 4. And looking through most of the problems in Newton, your answer is going to be left like this. Now, if they tell you in the instructions that pi equals 3.14, then you would substitute a equals to 4 times 3.14, and then multiply that together to give you 3.14 times 4, 12.6. But more than likely, your answer is going to be just that, just this meaning what I just circled. You shouldn't have to substitute pi in, but again, if they tell you to do it, then multiply. Any questions about that?
Nope.
Pretty straightforward.
Okay. So that's an example when they give you the radius. For the next one, we're going to work through one where they give you the diameter, and then we'll find the radius and then plug that into the formula. So 2, I've got a circle. And here my diameter equals 8. So we want to find the area of this circle. Oh, if my diameter is 8, then my radius is half of that, which is 4. And so now we want to just substitute that all into the formula. A equals pi r squared. A equals to pi times 4 squared. So A equals to 4 squared is 16. And bring down your pi. So A equals to 16 times pi. And that's it for that one. Any questions, anybody? All right, let's go on to the next problem. You may see something like this, where they give you one big circle, and then they give you another circle in the middle of that one, and they want you to find the area of this shaded part right here that I'm shading in. So for the outer circle, which is this one, it has a radius of 6. And then for your inner circle, this has a radius of 4. So then to find the area of the shaded region, so area of shaded region, well, that's going to equal the area of the outer circle minus the area of the inner circle. So now that's going to equal, okay, area of the outer circle is pi times 6 squared minus area of the inner circle, which is pi times r squared. And so this equals, okay, 6 squared is 36 times pi minus 4 squared is 16 times pi. And then 36 pi minus 16 pi is 20 pi. And so the 20 pi is the area of the shaded region. And I have seen a couple of problems in Newton like this. So this is how you set it up, and this is how you work it out. This makes sense to everybody?
Yeah.
Yes.
Okay, okay. Anybody still writing? Or do you have any questions?
I'm good.
Okay, thanks, Chloe. Okay, so now we're going to move from area of a circle to circumference of a circle, which is the distance around the circle, or like the perimeter of the circle. So circumference of a circle is, circumference is 2 times pi times the radius r. So that's the formula that we're going to use. So if I have a circle with the radius is equal to 11, then we're going to substitute r equals to 11 into this formula. So circumference is 2 times pi times r, which is 11. So the circumference is 2 times 11, which is 22. Then bring down the pi. So the circumference is 22 pi. Okay, and the next example will be find the circumference if they give you the diameter, which will take half of that, and then plug that into the formula for circumference. So I have this circle. Here's my center. Here's my diameter, which is 10. So that means my radius is going to be 5. So to find the circumference, I get C equals to 2 times pi times r. C equals to 2 times pi times 5. C equals to 2 times 5, which is 10, and bring down your pi. So the circumference is 10 pi. Any questions, anybody? This makes sense?
Yes.
Okay. Here we got one more problem where we have to find the shaded region, and then a couple of problems with Pythagorean theorem, and that'll be it for today. So suppose you have something like this. I have this circle with this diameter, and then I have this rectangle. But what I want to find is this, the area that I'm shading in now. And for this rectangle, it um, has a length of 6, and it has a width of 4. Now to find the area of the shaded region, well, in terms of this circle, I only need to calculate just what I'm shading in now, which is half of this entire circle. That's number one. Number two, since since this width is 4, but that side of the rectangle, then that's also the diameter for the circle. Well, only need half of the diameter, so I need just half of 4, which is 2. So 2 is going to be the radius that I'm going to use. Now let's write out what this is going to look like to calculate the area of the shaded region. So area of shaded region is going to be the area of the rectangle minus half the area of the circle. And I'm gonna stop right there before just working things out. Just want to make sure that that makes sense to everybody. Hafsa, Zach, Lexi, Jenna, Chloe.
Yes, I just need to write it, the area of circle part, and then I'm good.
Okay. Zach, Lexi, Marcos.
Yes, it makes sense.
Okay.
Yeah, but can you go back down?
Sure. Anybody else still writing?
No, I got it.
Okay. Lexi, you still? Or you good? Okay. A little bit. So now the area of the shaded region equals area of the rectangle, which is length times width, minus 1/2 pi r squared. So now that equals area of the rectangle is 6 times 4, and then minus 1/2 times pi times 2 squared. Yep, 2 squared. And so this equals 6 times 4 is 24 minus 1/2 times pi times 2 squared, which is 4. And so this equals 24 minus 1/2 times 4 is just 2 pi. In this case, let's add in the fact that pi equals 3.14. And let's substitute that in. So this equals 24 minus 2 times 3.14. So now this equals 24 minus 6.28. And 24 minus 6.28 is 17.72. And that is the area of the shaded region.
If the number of pi wasn't provided, would it just end off as 24 minus 2 pi?
Yes.
Okay.
Yep, Aaron sure would. That's a good question. Good question. All right, y'all, can I move on? Anybody still writing?
I got it.
Okay. So, Officer, okay, thanks. Zach?
I'm good.
Okay. Lexi, Chloe, Marcos, Jenna?
I'm good.
Good. Okay. So now we have, what, 2 problems for Pythagorean theorem, and that'll be it. Okay, so when we have triangles that have a right angle, that you have 2 legs. This side, this is your second leg, and then the longest side of the triangle is hypotenuse. Hypoto. Ah, man, checking this out. Okay. Hypotenuse. All right. And they're usually given some letter. This side may be A, this side will be B, and the other side could be B, and the other side could be A. And the longest side is usually given by C. So Pythagorean theorem tells us that when I square the longest side, well, that's going to equal to the square of the legs added together. So in this case, if I know that one leg is equal to 3 and the other leg is equal to 4, I need to find the hypotenuse. I'm going to just substitute in 3 and 4 into my formula here, and then solve for C. So that means C squared is equal to A, which is 3 squared plus 4 squared. So C squared equals to 3 times 3 is 9, plus 4 squared is 16. C squared equals to 9 plus 16, which is 25. And now to calculate what C equals, take the square root of both sides. And that leaves me just C is equal to positive 5. This is just a side note. Normally, when you take the square root of a number, you get a positive and a negative number. So square root of 25 is actually plus 5 and negative 5. But since we're talking about the length of the side of a triangle, well, the length can't be negative. So we're focusing on just the positive square root. So C equals to 5. And so for the next problem, we'll be given the hypotenuse and then one leg, and then we'll substitute that in and then solve for the other leg. But any questions about this?
No.
Okay. Okay, so for this right triangle, the hypotenuse C is 13. My side A, I don't know. And this leg B is equal to 12. So now let's write down C squared equals to A squared plus B squared. So C is equal to 13 squared. That equals A squared plus 12 squared. Okay, 13 squared is 169, which equals A squared plus 12 squared is 144. Need to subtract 144 from both sides. On the left side of the equal sign, 169 minus 144 leaves me just 25. And now that equals to A squared. And now taking the square root of both sides, we're going to get A is equal to 5. So that other leg of that right triangle had a length equal to 5. And that's it. And that's all I have for today. So any questions about this? Anybody?
I'm good, thank you.
Okay, thank you, Chloe.
Me too.
Marcos, Zach, Lexi, Aaron,
Thank you.
you're good? Okay.
Thank
Well,
you.
Have a good one.
Thank you.
all right, have a good weekend, and I'll see y'all next week.
All right, thank you. You too.
All right. And John, sorry, I have to leave you out, John. You good?